Okay, welcome back to my channel, Science Corner. Today we're going to discuss a few topics regarding electromagnetic induction. And the topics that we're going to discuss today is Lenz's law, transformers, and generator. Let's start with the basics of this. That's Faraday's laws of electromagnetic induction. Faraday's explained us that where there is electric field, there is magnetic field. And we can get something out of it. For example, when it comes to motors, we are using electric current, which is being converted to mechanical work. Whereas when it comes to generators, in generators, we do the opposite. Here, input is the electric energy and output we get as mechanical energy. Wherein generator, input is mechanical work and output is EMF. So starting with generators, we define generator as a device which converts mechanical energy into electrical energy. The principle on which the generator works is Faraday's law of electromagnetic induction. If we discuss about the construction of the generator, few things we need to keep in mind. The coil, the permanent magnets, north and south, coil, some mechanical mode through which we can rotate the coil, and here we'll join the circuit through which we would know that EMF is being induced. Okay. Again, there are a few things that are, sorry, I missed one part. There are going to be copper rings and carbon brushes. What is the working of copper rings, Mariam?
It makes sure that current flows in one way.
The working of copper ring is to take the current in and out of the coil, sorry, in and out of the coil. Copper rings these are copper rings, also known as, what is the other name given to them?
Split rings or
Slip
commutator.
rings, slip rings. And these complete rings are attached when we are discussing the AC circuitries. I'll explain you the split rings and the commutator thing that you just said. Coil is also known as armature. Now what happen is, sorry, okay, hold on. What happen is, when it comes to generator, when we mechanically rotate the coil, change of magnetic flux through the coil occur. Okay, something got stuck. नेट क्यों नहीं आ रहा? So,
Is slip ring and split ring the same thing?
no, slip rings, as I mentioned here, it's for the AC circuitry. And when we are discussing about split rings, which is also known as, I think so, the other one is more fine.
Oh, they're used in DC
Yes,
motors.
split rings are used in DC circuitry. Okay, one thing students normally make it's not a mistake. It's a major misconception that whenever we're discussing about split rings, so it has to be a DC motor. It doesn't have to do anything with the motor or the generator. It only has to do with the AC or DC circuitry. So if we are using alternating currents, that means we are using slip rings in the circuit, and if we are using DC circuitry or DC current, for that, we're going for that. So let's not mix these two things up. Split rings are also known as commutator.
So is the diagram that you're drawing like the magnetic relay thing?
Yes, I'm going to raise everything else, and I'm only going to discuss this thing now. So when it
Okay.
comes to what happens in a generator, that's a major thing that we're going to discuss. We know that there are split rings present here, slip rings, sorry. And sorry, we don't need to discuss the rings now for now. The thing that we're going to discuss, that we have this magnetic field present, okay? The magnetic field of the permanent magnet. So when we're discussing about this permanent magnetic field, it's cutting the coil. I'm going to use the invisible pen. Okay. So the here. The magnetic fields are from north to south and is perpendicular to this side A and B, which means results, whatever the results they are going to be produced on these two either sides. Because whenever we're discussing the motors or the generator, the only thing that we need to keep in our mind is that coil or conductor must be perpendicular to the magnetic field. So when it's perpendicular to magnetic field, it's cutting the coil. So it should cut the coil in order to get the results. So when the magnetic fields are cutting side A and B, and we are rotating the coil across the magnetic field, change of magnetic flux occurs through the coil. Due to this change of magnetic flux, that have this change of magnetic field, magnetic flux, let's just discuss what magnetic flux is first. Magnetic flux is defined as the number of field lines passing through a coil held perpendicular to it. So, if this is the coil and it's held perpendicular to the magnetic field, the number of field lines passing through this area would be known as magnetic flux. So its magnetic flux would be 3. So as we are rotating the coil mechanically across the magnetic field lines, number of field lines passing through this area changes. Due to this change of magnetic field lines, force is applied by the magnetic field onto the charges of the magnet of the conductor, and charges move across the coil. Okay, so if we obviously it's a conductor, it have free charges moving crosses. So magnetic field lines apply force on the charges, and and forces them to move across the conductor. So this move work done per unit charge by the magnetic field onto the charges of the coil present in the coil leads to EMF. And this EMF leads to current. So we mechanically rotated the coil of the generator across the magnetic field. Due to that mechanical movement, number of field lines passing through this area changed, and work is done on the field on the charges of the coil by the magnetic field, and this leads to the EMF. So what are the conditions that we need to keep in our mind is that the area should be perpendicular to the magnetic field. What is the second point? Change of magnetic field lines across the coil is very important. So, if the number of field lines passing through the coil is changing continuously, we'll have EMF. Otherwise, no. That is, if we general model, if we discuss that this is the coil attached to a galvanometer. So when I am moving the magnet towards the coil, the galvanometer will show deflection, but only as long as the magnet is moving towards it or away from it. As long as there is a relative motion between the coil and the magnet, will see deflection. If we're thinking that we are getting the deflection and I'll stop moving the magnet or the coil, we will not be having any deflection across the galvanometer will come back to its original position. That means the relative motion of the magnet and the coil is very important, because due to this relative motion, what is happening? Magnetic field lines are changing. So as long as the magnetic field lines passing through the conductor is changing, we'll have the deflection. And यहीं पे, using this concept, we can discuss Lenz's law as well.
Wait, so when the magnetic field lines are changing, EMF is induced, which causes change in magnetic flux?
No, 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 no. Change of magnetic field lines, number of field lines passing through the conductor is magnetic flux. So magnetic flux must change across the conductor to produce EMF. Did you get the
Okay.
point?
So when
That
change
magnetic
of
flux,
magnetic,
yeah.
no, say.
As long as the magnetic flux is changing, there would be EMF across the coil. If the magnetic flux is not changing, magnetic flux is basically the shorter form of, instead of saying everything that magnetic field lines passing through an area held perpendicular to it, instead of saying the whole line, we're only saying magnetic flux, which is basically change of magnetic field lines. So as long as the magnetic field line passing through the conductor is changing, we will get the EMF across the conductor, because as long as the field lines are changing across the conductor, we are getting EMF. So now discussing about Lenz's law. Lenz's law, in easier words, we say that in one sentence, cause and effect always oppose each other. Cause and effect always oppose each other. For now, just keep this thing in your mind, and we'll get to this point. Okay, what is the meaning of cause? What is the meaning of effect, and why they are opposing each other? Right? And discussing about the cause and effect. So here, if I let me take you to another screen, make a bigger magnet, north, south, coil, and galvanometer attached to it. So when there is a magnet is the cause, and due to the magnetic field lines entering the coil, the change of magnetic flux by this magnet will induce current into this coil, which we will see by the deflection of the galvanometer. So, when the change of magnetic flux due to this magnet is occurring in this particular coil and the current is being induced, so this current is the effect of this cause. Are we clear? The cause and effect thing.
Can you repeat it?
Due to the change of magnetic flux of this magnet, electro current will be induced into the coil. So this magnet is causing an induced current, which we're calling it as an effect in the coil. So the cause and the effect part. Cause is the magnetic
Okay.
field lines which are cutting this coil, and due to this change of magnetic field, current is being induced, which is the effect actually. Okay.
Okay.
So, so the cause and the effect. Now we're going to discuss the second part. So this magnet is the cause and the current induced into it is the effect. So the part we were discussing about Lenz's law was that the cause and effect will oppose each other. And why is this happening? So, when the cause, which is the change of magnetic field or magnetic flux through this coil, induce the current into it, which appeared as the effect given by the definition of Lenz's law. Now, this current will generate its own magnetic field. Now, this magnetic field will be generated in such a way that it will oppose the magnetic field of this magnet. और वो कैसे होगा? This will happen only if it will generate a magnetic field in such a way that it puts its north pole in front of the magnet. Now, when you try to move magnet further towards the coil, now the north and north obviously oppose each other. So, a lot of work has to be done to move the magnet further closer to the coil. But when I'll retract the magnet away from the coil, now due to the change of magnetic field lines, the direction of magnetic field lines, current across the coil that will also change. The direction of current across the coil will also change. Due to the direction change of current, we know that as we change the direction of current, the direction of magnetic field also changes. Are we clear on this point?
G.
When the direction of
It's like the
current
same
changes,
thing.
magnetic field lines, direction of magnetic field also changes. So when I am retracting the magnet, taking it away, now suddenly due to the change of current, magnetic field will also change. Now it will put the south pole in front of it. Now again, it will try to attract it now. In either way, if it's moving towards it, it will oppose it. If it's moving away from it, it will attract it. This opposition and attraction in either cases is the complete definition that the cause and effect will always oppose each other. And that's how it attracts and oppose each other. Okay?
Can you explain again from the work done part?
So when the magnetic field line is the magnetic field line is cutting across the conductor, we are getting induced current, right? Step one,
Hmm.
current induce हो गया, ठीक है? Now this induced current will generate its own magnetic field. Clear second point?
G.
क्योंकि when magnetic field is changing, current will also change, and when current is changing, magnetic field due to this current will also change, right?
Yeah.
So when we are moving the magnet towards it, the current induced will generate its magnetic field in such a way that it will put its north pole in front of it and it will oppose
Hmm.
it. it will not allow the magnet to come further closer to it. Okay, and why is this happening? Because due to the current induced by this magnet, it has generated its own magnetic field and now it's opposing the magnetic field of the magnet.
Okay.
And it's when you are retracting it, taking it away from it, so now the direction of current will also change across the coil, and due to change of that direction of current, magnetic field will change its direction as well. Now when there was north pole in front of it, due to that retraction and direction of change of current, now south pole will come in front of it, and north and south, we know, attract each other. So in either way, whether it's trying to go closer to the coil or away from the coil, in either case, it will going to oppose it.
Hmm. Okay.
That's what Lenz's law is. Now,
I'll
moving on to question number one of the worksheet, I'll explain you that question. So in question number one, part A, figure 8.1 shows a bar magnet suspended by a spring over a coil. This is what I was discussing to you now. Now, if we look into this diagram, here the magnet is the cause and the current induced into this coil due to this magnet will be the effect. Clear? So when the magnet will move up and down, change of magnetic field will occur, flux will occur through the coil due to which the current will be induced. Due to this up and down movement of due to this spring, the magnet will move up and down. Change of magnetic flux through the coil will occur and current will induce. Are we clear on this point?
yeah.
And this was the answer to part A, basically. Explain why the CMF
Maybe.
explain why the CMF is induced. So due to the up and down movement of the magnet, the change of magnetic flux through the coil occurred and EMF induced.
Can I just write change in magnetic flux?
Yeah, sure.
Okay.
So state what happens to the needle on the meter when the magnet is released from rest and is pulled up by the spring. So we know that we just discussed that when the magnet is moving up and down, the needle will deflect, showing that the EMF is being induced. So the question is the magnet is released from rest and is pulled up by the spring. So we'll say that the needle will deflect to the left and will return to zero.
मैंने यही लिखा है,
Deflect.
but I didn't say turn to zero.
And why is it zero? Because when it goes up and no magnetic field is cutting the coil, so the meter will come back to zero.
But
Deflect
is
to
it
left or right,
stationary?
whatever the choice is yours, and come back to zero. And why it's coming back to zero? Because when it's to the top of the position, it's completely up as no more magnetic field line is cutting the coil, so the meter will come back to zero. The magnet continues to oscillate up and down, moving in and out of the coil with the oscillation. What will happen if the magnet is continuously moving up and down? The deflection of the meter will be left to right.
Hmm.
Because it's going down, the meter will deflect in one direction. When it's going up, the meter will deflect in the opposite direction. Because the change of magnetic field and the change of direction of the magnetic field will lead to the change of EMF induced, change of direction of EMF induced. Okay? So
Okay.
the needle will oscillate back and forth. Getting back to the next part. The transformer question. This is a primary coil and this is secondary coil. How do we know that it's a primary coil? How do we know that a particular coil is primary? Because wherever the input is given as a primary coil and from where we're getting the output, that is a secondary coil.
Secondary.
So we are given input voltage, we are given number of turns. We don't have the number of turns of secondary, but we do have the voltage. What is the formula used when we have given number of turn? Vp over Vs is equals to Np over Ns, or in either way. Vs over Vp is equals to Ns over Np.
Hmm.
So Vs is 6, Np is 240, NS is to be found out, and this is 8,000. So rearranging the formula, making NP the subject,
200.
will have 6 into 8,000 divided by 240 will give us NN,
200.
200. So is it a step up transformer or a step down transformer?
Step down.
Yes, and why is that? Because number of turns of primary are greater than number of turn of secondary. So when number of so this is step up transformer. Otherwise, we can also judge by the voltage that the input voltage VP is greater than VS. So it's again a step up transformer.
Wait, you don't divide the whole answer with 2400.
Sorry,
Wait,
240.
yeah.
Because cross multiply होगी ना 6 into 8,000 divided by 240.
Hmm.
Getting on to the next part, they have asked us to the current in the primary is 0.50. Calculate the power input of the transformer. What is the formula for power input?
12 watts.
Power is equals to VI. The voltage input is 240 times 0.50. So the power would be.
12.
Now they have said in the second part that 90% of the power input to the transformer is transferred to the lamp. Calculate the current in the lamp. So what we can do here,
I did
we
90
can
over 100
we can
times
take
12.
90% of the input power. That will give us
10.8.
10.8 watts. Now we have the power output, which is equals to VI again, and V is 6 volts. So 10.8 divided by 6 will give us the output current. What is the answer to this?
Can you also just use the I equals P over V formula?
हाँ, so we are doing this P over V. वही किया है हमने. P is 10.8, which is the power output 90% of 12, and divided by V, which is
मैंने
6 volt.
240 से divide किया है.
Sorry?
The input is 240 volts.
बेटा हमने आउटपुट का पावर फाइंड आउट करना है, तो हम आउटपुट की ही वोल्टेज यूज करेंगे ना. व्हाई विल वी यूज द इनपुट वोल्टेज?
Because it's power input.
उन्होंने हमें पावर आउटपुट अक्रॉस द लैम्प फाइंड आउट करने को बोला. लैम्प इज अक्रॉस द आउटपुट.
No, they're
आउटपुट को
asking
लगा
for
लैम्प.
current.
हम्म.
वो करंट के लिए पूछ रहे हैं.
हाँ, तो करंट अक्रॉस द लैम्प आउटपुट पे ही है.
Oh,
वेरी गुड. व्हाट इज 10.8 डिवाइड बाय 6?
1.8.
Yes. Did you get the meaning out of it?
Yeah.
So IS is 1.8, power input is 12 volt. Easy question. They just asked us to label the questions, label the parts. So the upper part we discussed in the lecture already, that it's split ring, also known as commutator. These are the carbon brushes. What is the working of carbon brush?
Huh?
What is the working of
Oh, it
carbon?
holds the split rings together so it can rotate.
It's not like carbon brush are used to take current in and out of the coil, out of the circuit, and split rings are meant to take current in and out of the coil.
Also,
So
you explained slip rings, not split rings.
split rings are used to keep the direction of current in the coil same. So when,
I said that.
huh, so
And you said I was wrong.
split rings? No, I only said के don't mix split rings with slip rings. मैंने सिर्फ इतना बोला था. The split rings
Oh,
are the for the DC circuitries, and we do not associate it particularly with the motors only. A split rings is somewhere we use where we need DC circuitries and direct current हमारे पास आ रहे हैं. इसमें तो वैसे भी उसने बैटरी अटैच की हुई है. बैटरी वैसे भी डीसी होती है. इसमें तो करंट वैसे भी चेंज नहीं होना था डायरेक्शन में. अब द फ्लेमिंग्स लेफ्ट हैंड रूल इसमें अप्लाई होगा. ओके. फ्लेमिंग्स लेफ्ट हैंड रूल के अकॉर्डिंगली एफ बी एंड आई. थंब index finger, and middle finger for current. So we know the direction of current is always from positive to negative. So coil के across यहाँ पे current downward होगा, यहाँ पे current क्या होगा upward. And direction of movement भी उन्होंने हमें show किया हुआ है. The direction of movement is clockwise or anti-clockwise?
Anti-clockwise. No,
Clockwise.
clockwise.
Clockwise. We have the direction of motion, that is F. We have I. Let's see उन्होंने question क्या पूछा हुआ है यहाँ पे. They have asked us suggest which of the two magnetic pole X and Y are the north pole. So what comes to your mind? We'll just
Why?
simply will put F, B, and I in order. Okay. And if on this side, if the force is upward, we could say that it's a north pole because it's going in the
North Pole.
clockwise direction. Are you thumb pointing upward on this side on which I've drawn the arrow?
Yeah.
Which means this side will go up. So justifying the point that it's going in the clockwise direction. So X will be considered as north pole. Okay.
Okay.
So just
Yeah.
two changes that causes the motor to spin faster. What will be the points?
Increasing current and using a stronger magnet.
Good. Then we have next part. In the next part, we have state the effect of the motor in reversing the connection to the battery, the coil. What will happen? Now the coil
Direction
will
of
rotate in
current will
the
be reversed.
opposite direction. Good. The battery in figure 9 is replaced with a resistor. The coil is made to rotate by an external. Explain why there is a current in the resistor. Now they have said that they have removed this and in place of it they have attached a resistor. Why there is current in the coil now, in the resistor? How would you justify that?
Hmm.
Because when the coil is mechanically rotated across the magnetic field due to the change of magnetic flux through the coil, EMF is induced, which will appear as a
Oh,
current passing through the resistor. Now it will become a generator now. We are
hmm.
mechanically rotating the coil and due to the mechanical movement of the coil, change of flux across the coil will occur, and due to that change of flux, current will induce in the coil, which will appear across the resistor.
Okay.
Done?
Change of magnetic flux occurs, which induces EMF.
Which will appear as a current across the resistor.
Hmm.
Now, the next part is we have a next question. They have said the apparatus in figure 10.1 is a part of an AC generator that is connected across between and A and B in the coil. अब उसने क्वेश्चन बहुत बहुत बेसिक सा पूछा है कि इट्स एन एसी जनरेटर सो अक्रॉस ए एंड बी हम क्या अटैच करेंगे
Slip rings.
स्लिप रिंग्स वेरी गुड slip rings attached to carbon brushes which will be attached to C and
Hmm.
D. Now they have asked the variation of current across through resistor in the coil. So we know that when we are discussing about AC circuitry, so the graph across an AC generator is always variable.
Varying.
So we'll draw a
Yeah,
variable
there's
graph
the maximum and the minimum.
minimum like this. Or we can, if we have increased the speed, what will happen now?
There will be greater frequency.
Now we will have more. They might have
So
asked it.
do I only draw like one maximum and one minimum?
Well, that's enough. Then we can draw on a straight two ways in which the graph would be different if the coil spins faster. So that if the coil is spinning faster, we will have, what will we have?
Greater frequency
Yes.
and like
Greater,
less
greater
space.
amplitude, more
Yeah.
peaks, or more current across it. Higher frequency. The very first point that you said, higher frequency
Hmm.
and more peaks, more amplitude, and then we have suggest what could be connected between C and R so that the current R is always